All right.
Yeah.
So, where should we
Okay.
start with
Namo
masonry?
Om Vishnupadaya Krishna Prishnaya Bhutale
Aya
Srimati
Bhutale,
Bhaktivedanta
Srimati Bhaktivedanta Swami Namane.
Swami.
Namaste, Saraswati Devi, Gauravani Pittarana, Nirvishi, Shekhinari, Pashkapadi, Pittarana.
So, Hare Krishna, dear devotees. We This series of discussions that we are having, specifically with Hari Kirtan Prabhu's experience and his sharing of knowledge, is about building material. Srila Prabhupada has many times talked about becoming self-sufficient in shelter, especially from local materials. So last week we discussed about log cabins, and he specifically talks about that. Ramananda Prabhu posted this letter, which I will share. So he says in a letter to Kirtanananda in 1973, yes, go on acquiring the surrounding lands, and in this way we will establish a local self-governing village and show all the world a practical example of spiritual life as Krishna himself exhibited in Vrindavan. Agriculture and protecting the cow. This is the main business of the residents of Vrindavan. And above all, simply loving Krishna. The cows, the trees, the cowherd men, and gopis. Their chief engagement was loving Krishna. And in New Vrindavan, we want to create this atmosphere and thereby show the whole world how practical and sublime our movement is. I shall go to New Vrindavan, Vrindaban, as soon as your palace is finished. Jai, for the small cottages, I suggest to construct as the diagram below. Wooden beams, and between the beams filled with gravel cement. The roof may be tile. The size may be 12 by 15 feet. This design is especially suitable for grihasthas who can feel very comfortable there. And you may house 4 brahmacharis in such place. Every day you can build one such house. 10 may be required in 1 month. You will have 30 such nice shelters. So this is of course the log cabin design that we were discussing last week. Harikirtan Prabhu very well he explained the pros and cons of it in the current building construction regulations and the process and what is acceptable and cost wise energy. We discussed many angles of it, and specifically the advantages as we discussed were that it is easy and cheap to build the walls, much faster from the local material. But the disadvantages were a lot. Harikirtan Prabhu explained that it contracts in winter time and it expands in summertime, and it is difficult to protect from insects and mold, and it's breezy. It gets air and out and in and out much easier than like enclosed or covered homes that we have now, because those are built for keeping heat inside. But and the codes are such that the insulation and everything is focusing towards that. But if somebody wants a house which is not so comfortable in a sense that it has all these, one doesn't mind having some insects and bugs, and heat also is not so sufficient many times, then, or someone has to do wood furnace quite often, then one could go towards the log cabin thing. As far as cost is concerned, regulation is concerned, it's very difficult to save too much cost because this is only the wall construction happening. Otherwise, the foundations we have to dig through a professional. They build the foundations, and the roof we may have to get some professional to do, and then all the electricity, plumbing, all those things come in. Those are all specialized, labor intensive. So it's tough to save costs overall on housing, but we are trying. We will keep working on these discussions, how to do that. And Hari Kirtan Prabhu today is going to take us through masonry. He says many of the advantages which log has we can keep, and also disadvantages can be curtailed. So let's hear from him. Prabhu.
Hare Krishna.
Hare Krishna, Prabhu.
Well, let's see. There we go.
Hare
Hare Krishna. So, yeah, thank you for giving a kind of a recap or a summary of what we discussed last week. So with masonry, just as you have with wood construction, there starts with like the most simple forms, and then you can get more and more complex and more elaborate. And there's a variety of old, ancient construction methods, and then of course modern construction methods. And to start with, the simplest, and this is kind of like the log cabin equivalent, would be cob. As Anna briefly mentioned last time, the Cobb Cottage Company, this cob building method, this is an old method from England. And we see a very similar method. It's nearly identical in the construction of the mud huts that they do in West Bengal and in various places around India. Yeah. So, Chintamani, can you
masonry? What is masonry? Like what?
So masonry is going to be more like stone and brick,
okay.
And
so,
then, but I'm considering this all to be under earthen construction, because masonry and other earthen construction methods, they are all using the same materials. Some are fired, some are not, and some are like more cementitious materials.
I see.
So cob would be a mud hut or a mud house. This is traditional English and Welsh, actually, Welsh style building. And then you will see in the villages in West Bengal and all around India, this was the same similar style. Generally, it wasn't 2 stories. They would do smaller houses, but it is also built out of mud and the same method. And the method is, it's a certain mixture of clay and sand and straw. And it is built by slump method. So the walls are literally built up like you would build like a sandcastle or a children are building a mud structure. You're just piling the mud on top of its.
Do you need a foundation still for these walls?
So it's interesting. A foundation is there to provide a foot for the building. So with the Cobb Cottage Company and the buildings and the traditional ones in Wales, they would do a foundation out of stone, like field stone. But some of their experimental buildings, they did not. They built the mud right onto the ground. And that's what you see typically in the huts in India. And the idea is to remove the base of the wall away from where water will flow, because this is not a cured or a fired type of earthen work. This is not cement or lime. This is just clay, and it's mud. And so if the building sits on the ground level, on grade is what they call it, but if it sits on ground level, then when you have heavy rains and the water runs around your structure, it'll wear away at the walls. And so you want to lift that mud away from the ground with a foundation. They did do some experimental ones where they graded the earth away from the house, and they worked just fine, but they were smaller structures, and it was acceptable. The thing is that even though it's not necessary to have a foundation, I doubt you will get any kind of occupancy approval, or it will not be approved by the state as a viable structure without a foundation.
Well, what
So
about the pikes on poles? We could do that on log building.
anytime you're going to build a structure like this of earthenwork, so that here's one of the things with an earthen structure. The weight of your building is tremendous.
Uh-huh.
And so building it away from the ground on stilts or on legs is not very practical. This is what we ran into when we were looking at our own cabin. We were considering filling the walls with like a mud or a an earthen material, like Srila Prabhupada was saying just in that quote you read about filling the spaces in between with this gravel and cement. And the issue is that the weight on our supporting structure would be too great. So we had to go with something light, and that's why we opted to go with wool. Now the earth can bear any kind of weight you want to put on it. So the weight of the house is not an issue if it is sitting directly on the ground or on a foundation, a stone or earthen foundation.
So this is
One
what
of the
Srila
interesting
Prabhupada is talking about, no? Just building one cottage, like one room cottage like this
Yes,
for the
yes,
whole
simple
family.
structures, not so elaborate. The idea, and I don't know for sure. I'd have to speak with more, but from what I can tell, the idea is that you build a small house that is sufficient to have, it's simple. It's a simple construction, and um, it's a place to sleep and basically live. But your majority of your activities are out of the house. You're doing your service and you have your work in the community that you're doing, and so the house is not there to like fulfill every need.
I see.
It's not there to
So when you're trying to work from home and do a lot of computer work, that's where problem happens, right? Because then you are on
well,
top
yeah,
of the other.
and then also you are trying to school from home, and it's just so many different activities that you do in the house, and now it changes the necessity of what the house has to provide.
See,
And
but in,
so
in Rajasthan, no, I've seen,
hmm,
you see, and so there the homes are, let's say, like this, you see. So let's say one compound will have three or four cottages
yes,
like this.
yes,
They also people had different, like one was kitchen, one was
yeah,
like
which is a
bedroom,
very interesting style of construction. I've observed
one.
that also in West Bengal. The villages have the same structure where it's a compound, and each building is an individual room with a purpose. So you have a bedroom, you have a kitchen, you have a storage space. Like they're arranged around in a little circle almost.
Mm.
So, and I think that's an interesting avenue to explore. I think it's very interesting. And that was something that they were experimenting in Aprovecho, in the Cobb Cottage Company in Oregon there. Is because of the regulations, if it was 10 foot by 10 foot, if it was less, it was 100 square foot or less, they did not require any building permits. And
See,
so they
it's
were like,
like
oh, we can do this. Yeah, just like that. So they were experimenting with that with their Cobb buildings. And it's doable, but it really depends on the climate. Down in Florida, this is much more doable because you don't have the weather is not such a concern. In New York, this becomes problematic because, of course, during the winter, you don't want to be living outside. So,
well, in Florida also because of the hurricane issues, no? They want the construction to be really, really strong. The
yeah,
walls, the foundation, the roof, everything has to be of like really thick and strong with beams
yeah,
supportive,
yeah.
everything.
So these
So,
are some things that we'll run into, but the most easy construction is, or most basic, simple, it does not require much skill. It's a very straight, very basic, very natural construction, very forgiving, is cob. Now, cob has been extensively tested and demonstrated, and it is an approved building method in the United States. So these can get approved as livable structures. You know, again, you'd have to go to find out specifically what I see adapted techniques and various things. So there are certain things that counties will require in order for them to be approved, but
per foot.
It's very low insulation value. It's very low. Yeah. So here's one of the fundamental differences between masonry buildings and wood buildings.
Okay.
Masonry buildings have a tremendous, or earthworks buildings have a tremendous thermal mass. So with all that weight of the material, you have also all of this thermal mass. And if you can heat that thermal mass, there's various creative ways to do that. Your heating system runs either radiant heating, where you run hot water pipes through the floor or through the walls, or you run what they demonstrated in with the Cobb Cottage Company. They put their chimney pipe, they ran it underneath benches, so the benches were warm. They had these earthen benches in one of the houses that they were testing. And that's where they used the rocket stove. And they had the rocket stove, and it would heat up the bench, so the bench was very warm to sit on. It's very pleasant. And so you start heating the mass of earth, and then rather than trying to contain the air inside the building, rather than trying to prevent the transfer of heat through the walls, you heat the mass of material, and that radiates the heat back into the living space throughout the day. So you're creating a warm battery, essentially. Your house walls become a warm battery, which keeps the interior comfortable. And that is what we see in a lot of the old temples and old structures in India, where it's blazing hot outside, and you go into the temple and it's very cool, very comfortable. And that's because the stone and the earth, the mass, the thermal mass of the building is so nicely, constructed and engineered that the heat, it just never becomes oppressive inside the temple.
Very interesting.
So that's
very, very interesting. This is.
It's a different approach to maintaining heat and comfortable temperatures inside the building. So it's the same principle that allows keeps coastal regions and anywhere around a large body of water, the climate becomes more temperate.
So current architecture engineering policy thinking in the US, in many of the states, is that you close the home, make it completely like airproof, like really packed, and make the insulation really high, and then heat it with electricity, especially with these heat pumps, very efficient heat, air heat,
Yeah.
and maybe put solar panels on the top.
Yeah. Yeah.
And because they use so less electricity, that it can save it in the battery, and then that's how it can heat. And
Yeah.
so what do you think of that with the stone masonry?
I mean, the stone masonry, so what you'll find is you'll find, because ways of thinking about heating and cooling a building have stayed the same, heating the air inside the building rather than heating the walls. Most modern masonry structures incorporate insulation into the walls. So you'll find a brick structure, and it has a styrofoam cavity in the center of the walls. Or they'll have some sort of there's a construction method where you use these foam forms to build the home, and then you pour concrete in the cavity in the center, And then that's a method for building. It's very rapid, very modern building. And the foam insulation gives you your R value, whereas the masonry gives you your structure. And that's how they approach it. But that thermal mass can be used to your advantage, as a battery. And unfortunately, commonly, modern building methods don't take advantage of that. So this is more like significant and more important in warmer climates, because cooling a building can become very costly. And there's not as many alternatives to cooling a building as we have to heat a building. There's many ways you can heat a building.
Florida, it would be good to do something like this, masonry, because it's strong.
Also, you have a bigger problem with bugs and mold in the warmer climates. So
Right.
masonry is eliminates those as a problem as well. So.
Why do they build with wood then in South?
It's just what it's
Pushed.
So in the uh, in the Northeast, or like where you are in North Carolina, these places, if we build with masonry, where do you get the material locally? I mean, are there quarries? How much is the cost of like, what are you talking about? Stone blocks, or you're talking about um, bricks made from like fired bricks?
So we can get into those different methods now. So initially we talked about cob. That was the simplest and the easiest. And then we can go from there and we can talk about Earthbag, which is also very easy. Does not require, like, anyone can do it. It's very simple. And that also does not require any specific type of soil. With cob, you have to have a certain clay quantity or content in order for it to work. Earthbag literally is, you would get these bags. Usually they're like a plastic, like a cement type bag or a burlap, but a plastic burlap, because it should not degrade. It shouldn't break down. And you fill them with earth and you stack them. And it's like working with bags of soil. And you can see some of the structures. So there you go. So it's very easy. Some of the ways to do it is using a tube, just a tube of material, and you just keep filling the tube of material and stacking it. Or you have individual bags. It's, very simple construction method. Very intuitive. No special skill is required. Relatively unskilled labor is okay. And that has been demonstrated as well in this country. And it is something that I don't know how extensive it has been approved, but it definitely is in some locales. It's definitely approved as a building. I've actually been inside several buildings that were Earthbag, and those are also very nice. The R value, I'm not sure on the R value on these, but again, we're looking at thermal mass over R value is kind of the way we think of masonry buildings. Yeah, yes, Bharat Prabhu, very cost effective, very sturdy, and again, the labor is cheap because it is not skilled labor required for this. Maybe you have one foreman or somebody who has a little bit more understanding of construction, but for the most part, you can get the community involved. A family can build it. It's very straightforward, very simple. So,
what about the external walls?
So the Earthbag is finished much in the same way Straw Bale would be done, and that's where you attach a mesh, and then you're going to put plaster over that.
Okay. So why would one use this compared to straw bale? What are the advantages, disadvantages, pros, cons?
So the material is basically free because you do not have to have any specific soil requirement. So some type of earth buildings, you have to have a specific ratio of clay to sand and like this. This, literally any kind of soil you have in your site will work, because all you're using is you're filling the bags. The bags are providing the structure for the individual cells. And so the clay to sand to loam ratio is kind of irrelevant, really. Whereas straw bale, if you grow the straw, that's different. Yeah, see, it has a low R value, but a high thermal mass. Yeah.
What does that mean?
So an R value is the value, it's the measurement of how it resists the conduction of heat through the wall. Right? So like a thermos, you can put something hot inside it, and the heat does not transfer through the thermos to the outside. Right?
So keep the heat, but it will not allow it to, but not stop it.
So R value is a measurement of how well the wall resists the transfer of heat.
Okay, I see.
So that's what it's R. R is the resist factor, or the resist value.
Okay.
So then the
Cold
thermal
or
mass, yeah, cold or heat. It's just the movement of heat through the wall.
okay.
The higher the R value, the more it resists the transfer of heat through the wall. So from outside in or inside out, either way.
Okay.
Then thermal mass is the amount of heat that the wall can actually hold,
Uh-huh.
or the amount of cool. Basically, how stable it is in temperature, how much temperature, the higher the thermal mass, the slower the material will change temperature. Think of a large stone. It gets hot, and then the sun goes down in the sun, and the sun goes down, and you can put your hands on it, and you can feel, oh, it's still warm from the sun's heat. So that's thermal mass. A large stone has a lot of thermal mass. It has absorbed the heat, and then
In
it
colder
retains it.
climates, you need better to put straw bale, and in
It does exactly. It's in colder climates, insulation is better because heating is more of a factor. In warmer climates, you really want thermal mass because you want to resist the structure heating up during the summertime. It's much better for cooling.
so this is basically the strength, the wall, the basically the strength and the structure of the insulation, not the outer plaster, but it can
Correct.
give good strength to it. See.
Correct. Correct.
So earth bag is good if there is rain too, right? Compared to, let's say,
Correct. Correct. It's not impacted so much by water and rain. It really doesn't erode because the bags are giving it that structure, and so the soil is contained essentially inside the bag. Yeah, so it's also faster, and it's better it's more stable. So cob is very slow. And the reason is you can only build something like 6 or 8 inches of a cob wall, and then you have to let it cure, or it has to dry. And so it's the slump method. You have to build up a certain amount, and then you let it dry, and then you build up a little bit more, and then you let it dry. And so the process is very slow.
and it's
And
season
that's why it's,
dependent, like
yes, very season dependent, because if it's not dry enough or warm enough, it's not going to cure. It's not going to dry. Whereas Earthbag really doesn't matter. You just don't want to be working with some soil which is too wet. That's all. It should be relatively dry.
Mm-hmm.
So, but it's very forgiving. And so that is, the advantage of Earthbag. And so for structures now, again, Earthbag does not lend itself to structures that are more than 1 story.
Okay.
You can do that, but it's not ideal. It's better. It works very well, and the cost is ridiculously low if you have the labor to build single story structures. And they can be large. They don't have to be just small. Like you can have a full size 2,000 square foot house or whatever, but it's all has to be 1 story. That's fine.
Mm-hmm.
And there's no drying time. Like, here we go. This is a good summary of it.
I see.
So you're limited, then your footprint starts getting bigger. Like if you want to have larger structures, then you cannot go up so much with Earthbag. I mean, you can, but it's not ideal. And so you're looking at larger footprints to accommodate larger buildings. That's where we move into the next method of earth construction.
Before we go ahead, so looks like
Sure, sure.
it will be good for northeast, cold and wet, and
Hmm.
earthbag would be good for places like Florida, which is wet and hot, and
Hmm.
cob will be good for southwest, like Texas, Arizona, places like that, which is dry and hot.
Yeah. Cob is very similar to what we would consider adobe in the
Okay.
US. Adobe is traditional in the Southwest. And so it's kind of the English equivalent.
Mm-hmm.
Earthbag is also known as super adobe. Now, I think that kind of what we're getting at is the combination of log or timber framed with straw bale infill is going to be the best for your area in New York.
Mm-hmm. That's what our nearby neighbor does. That's what he does. Frame with the straw bale.
Yeah, you use timbers, so you can harvest the timbers off the land. You can
Yeah.
grow the straw,
Yeah.
and the main thing is you get a nice foundation, and then you build your timber frame on top of that, and then your straw bale. And you can build beautiful two-story structures, whatever you want, really. There's not really any restriction. And they will be very, very nice for New York State and basically any northern climate.
So log cabins also have thermal mass. Log also.
They do not quite as much as earthen structures, but yes, they have more thermal mass than the standard stick-built structures. Yes.
I see. Okay, please carry on now. Now a little bit clearing. So foundations we have to build either way because of the
Yeah.
cold strength of the building and the structure in hurricane and everything. It gives a footing,
Yeah.
right? This given, and then you
Then,
build walls, which we just discussed. Yeah,
yeah. So then the other method of building that we
yeah.
moved on to, and this is what you and I, when we first met, we saw when that was the compressed earth block. So now we're getting to a more
Uh,
structured way of building with earth.
uh-huh.
This is getting closer to bricks, but it's not quite as involved as bricks. Bricks requires firing, and it's a very specific process for firing and everything like that. But earth block, compressed earth block, no firing is required, but it is a formed structure. A specific ratio of sand and clay is needed. And so you cannot use soil from anywhere. So it's a little bit more specific. You may have to bring in extra clay or extra sand to get the right ratio. But if you can, so here's some of the advantages of this type of building is that you can make it on site without having to fire the blocks. So it's a mechanical process to compress them, and the machinery is relatively inexpensive. And then you can make blocks all year long. You can have somebody making blocks and storing them. And then as soon as the weather is favorable, or you have a foundation or a building that wants to go up, then you can begin constructing with those blocks. And so that allows for very rapid construction and relatively inexpensive materials because if you're able to source the soil from your own land. So they're typically larger than bricks, so the construction goes faster. And depending on the shape of the blocks, either less mortar or no mortar is needed in between them at all. Like you can see, some of these have the holes and the little not those ones, but if you go further up, they have the bumps and they lock together essentially. So it's not even needed. The mortar is not necessary. Depends on the structure, of course, but
I see.
and so this takes earth construction to a more professional level, but also it simplifies, because constructing with mortar and masonry, that becomes a very technical skill. Really, it is. It's there's a whole category of masonry. Masons and mason workers this is a very highly skilled field, and so this is kind of halfway there. ICEB, that's the foam that I was telling you about. So yeah, interlocking. Anyway, so yeah, so there you go. You can compress them in those shapes. There's different forms you can compress them in, and this allows for relatively rapid building. And this is kind of like on par with what is called rammed earth, and they're very similar. So the compressed earth blocks, you make the blocks ahead of time, you store them, and then you can place them to construct the house. The rammed earth, it's a very similar type of material. The ratio of earth and yeah, so sustainable high thermal mass building techniques using site source soil. Exactly. And the rammed earth is built, the walls are built in place rather than constructing the blocks and then assembling them later. It's massive monolithic construction of the walls. And the you have to build forms in which the earth is placed. So yeah, so there you go.
So this
Yeah,
is
the compressed earth.
or more warmer climates.
Yeah, these can be used in both. It really depends on how you insulate your structure. Rammed earth and compressed earth block have been used in Northern Europe, and they use a foam insulation on the inside in order to maintain that. It doesn't have much of an R value, but it's much more. So there you go. It's even less than logs. Logs have a R1 per inch, and this is like you'd say pretty safe to say half R, 0.5 R per inch. So it's half the value. So definitely better for warmer climates. You get that high thermal mass. But they do use it with insulation on the inside. So
why would you use this instead of earth bags?
because this you can build up as high as you want. You can build multiple story structures. So I did a cost analysis, and really compressed earth block, here's where your cost starts to get distributed, because you only pay for the machinery once. If you buy the machinery to compress the blocks, you can set up an area where you are producing the blocks, and then that can go on throughout the year, and then the houses are built from the stockpile. So if you're only building one house, the cost of the machinery is an added cost. Once you're done building the house, you don't need it anymore. So it's not really a worthy investment. But if you're building many, many buildings, then the cost of that machinery gets distributed across the buildings. Every building you build is now decreased the overall cost of every building that you have built. You keep distributing that cost. So it becomes very cost effective the more buildings you construct. And then also being able to build 2-story buildings, or even larger. If you had, a hotel or something, you can use the compressed earth blocks. You can build a hotel, 2, 3, 4 stories. It's not a problem. Whatever, however big you want to go. Yeah, so you can see here, it works
Both are
really good.
ideal for high diurnal temperature swings, hot days, cold nights.
Yes, you'll find that more in drier climates. So out in the southwest,
West will be good.
And the thermal mass is what really helps with that, because during the day, the building heats up. At night, it cools off. The high thermal mass moderates that. It softens the feeling inside the building of that swing, because it absorbs the heat during the day and then it radiates it back out during the night. So the temperature of the building never quite changes. So that's where your advantages are there. But I find that the advantages of earthen structures are very good in warm, wet climates because of the resistance to mold and bugs and things that typically will just destroy your buildings very quickly. So
Kirtan Prabhu, may I add one little thing?
please do.
Yeah, regarding the Earthbag buildings, it might be of interest specifically for Nima Prabhu that often they are being built round, in a round structure where no roof is needed, because you close the roof by becoming closer and closer, going into a circle that becomes more narrow towards the top. So you could build very inexpensive brahmachari housing.
Yes, you can do that actually. These domed structures. Yeah,
dome.
Absolutely. Yeah. You can get very creative with the earthen construction. They get very they're very fluid. The structures are not so constrained as we're used to seeing with wood structures. I mean, you can get, it's very forgiving. You can get it, you can play with it and do all sorts of interesting methods and ways of building. So yeah. So it's a fascinating approach to building it and to working with this material. And then of course, after you have compressed earth block, then you get into the more familiar brick and concrete stone concrete block and like that structures that were more modern building techniques. I'm not as interested in those simply because you don't really have the material savings that you get with the compressed earth block and the rammed earth and the cob and like that and the earth bag. They have the same moisture resistant and bug resistant properties, the concrete block and brick, but you have to purchase the materials, and they're very you require highly skilled labor to build with them. So
the concrete
that's kind of
available in the market.
Yeah, you see that in Florida a lot, the cinder block construction.
Yeah, it's a big deal.
Yeah. It's a huge amount of the buildings in Florida. And so yeah. But it's you have to have masons to build it because mortar is needed, and you have to purchase the blocks, and so really you're not getting so many advantages from building in this way.
But you can go many floors, big.
Yeah, but you can do the same with the compressed earth block, and you can source it from your site. So,
like, what is the regulation for compressed earth blocks and rammed earth blocks?
Rammed earth is, from what I understand, because I've worked with a guy who did this in Vancouver. Rammed earth is a I've seen it. It's approved in many areas, and they have regulations on how to do this, and so it's a well-known building method. I'm not sure on the compressed earth block. Okay, so there you go. You have it. So I would stabilize the blocks with cement or lime, definitely. That would be my preference. I would use lime. I would stabilize with lime. And okay, so they require vertical steel.
Yeah. Because they are 175 miles an hour. You have to.
Yeah.
Whereas even concrete blocks, they want steel every like 24 inches or something
Yep, yep.
with concrete blocks.
So that's why I lean towards the more older construction methods, or the more, the super adobe, the cob, or the compressed earth blocks, because that's where we see our advantages for our construction, the projects that we're working with.
In North
Um,
Carolina, where you don't have so many. See, now the
well,
problem
no,
is
even in Florida, it would be advantageous, but they have their regulations for what has to be done in order to make it hurricane proof.
so tell me again, what exactly are you proposing now?
No, I'm just saying that for cons- construction in um, Florida,
Uh-huh.
the the use of either compressed earth blocks or super adobe or such, these other methods, we would have to see what regulations have been established to maintain the integrity of the structure. But because you don't have to purchase the materials, I see that as a great advantage, that you can source them from the site. Now, I don't know in Florida how much clay you have on your land. What is the composition? It may not be any kind of advantage. That's a big consideration. It may be a lot of sand, or a lot of, not appropriate for cob or compressed earth or rammed earth. So that may be a difficulty. Um, that's where Earthbag would come in, make sense. But then I don't know if that would meet the standards for hurricanes. So these are all factors that have to be thought of and considered.
Nowadays, I mean, it's not just limited to Florida. We are getting all these tornadoes all over the country.
Yeah, I
And
wouldn't be too concerned with that in New York. But again, I think we've established that in New York, the straw bale construction is more advantageous. It'll be easier to heat and build. So for New York, um, the benefits would be timber frame, because you have the timbers on the property, and straw bale, and you grow your own straw, and then that can be very, very effective, very cost effective, very, you know, very easy to maintain the heat. Yeah, that could be a very good building method.
I have one thought coming up.
Sure.
It might be good for Florida to have a hybrid strategy where you could use the Earthbags for simple and cheap, fast building of Vedic style buildings, where you want to show, okay, here's a temple, something is happening, and also for more idealistic Ayurveda practitioners that like such rounded buildings, or something that's looking a little bit different than the usual structures, and then to combine that with other structures that the doctors that are more conservative can see. And you could, for example, if you build something like a facility for producing coconut, you could showcase also how like two different techniques look like, something for a temple like the Earthbag, and then something else with rammed earth or these bricks.
Yeah, yeah. I mean, I think that's a good avenue to kind of combine where it's useful.
Mhm. So
So
regulations is a huge problem.
it
And many
is.
times the regulations are like you mentioned about the insurance companies, but the insurance companies are also coming with the point of view of damages in extreme circumstances.
Yeah,
You know, So in Florida, I mean, normally you don't get, but sometimes you may get, and then the insurance companies have to pay up. So
Yes.
all the construction is basically towards preventing those once in maybe 30 years or 50 years,
Yeah, exactly.
which is important too.
You will find that the earthen structures will last longer in Florida with less problems because you will not have mold problems, you will not have bug problems. You know, these are things that you don't. And this is in my work, I have seen over and over again. I pull open a wall and the wall is filled with carpenter ants, or you pull it over, there's termite damage, or the entire wall is filled with mold, and you have to tear out all the material and treat it, and you know, over and over and over again, hundreds of houses, and it's quite disappointing to see it again and again.
And
Because you,
regarding earthquakes or hurricanes, all the dome structures that have some elements like arcs that resist such
yeah,
conditions very, very strongly. That's proven scientifically. So they should be better for insurances, better rated.
yeah, you will find though that typically the regulations do not follow. Maybe not typically, but you will run into it often enough that you will notice that not all the regulations follow common sense or like what makes sense. It is you know, there are bureaucratic reasons for various regulations. You can work with them, but it's not, you know, not to be expected that it will match. So it's something we have to play with. We got to work with. You know, it's not something we can get around. So yeah. So in the and I think the idea, Bharat Prabhu, that you were expressing about using the earth bags for different structures, maybe utilitarian structures, maybe you want to demonstrate with a temple how it is constructed or different. I think that's great. And I think that there's a lot more room. I'm not sure. It's been a long time since I looked at the building codes in Florida, but from what I remember, they're less restrictive than New York.
Yeah.
It's not. They still have significant building codes and regulations you have to follow, but they're not as strict as in New York.
So I think one needs to talk to the county and see what allow.
Yeah, exactly.
It's not going to fill your belly right now. Any questions to ask Hari Kirtan Prabhu till now? Whatever we have discussed, or any points to make? Anyone? You can think over it. If you don't have suddenly, then interject anytime.
So with some of the notes to keep in mind, with any of these structures, again, I was kind of making this point a lot last week, and that was larger overhangs really extend the life of your building. With the straw bale and with the cob construction and the log cabins, everything, you can push the water away from the building, then we'll extend the life of the building. So also with a good foundation, good tall foundation that lifts the building away from the ground, you know, and large overhangs, then we can protect any of the material that is damaged by water.
I have a question in this regard. It seems that the roofing is always the most expensive part, and what alternatives do we have with roofing? And then also I'm thinking about the foundation, as there. As we spoke about the walls a lot, but not about the roof and the foundation. What alternatives are there, and how costly are they? How long lasting?
Right. So as far as foundation, we call it in the builders and in the like when you're working with houses, they call it the boots and the hat of the house. So your foundation is your boots and the roof is the hat. And the foundation is very well established. There's not, at least not in my experience, and maybe others have done more experience in this, but from my experience, the foundations that we build, modern foundations they don't have a lot of downsides. There's not a lot of drawbacks to them. They're very well thought out, very well built, very well designed. The materials we use, it's not a lot not a lot of improvement, I guess you could say, in there. There's an interesting thing that I have not studied. I haven't really delved into, but I have observed, and that is, I have seen buildings with concrete foundations, and the wood that is touching the concrete tends to rot out. And then I have seen buildings, old buildings, with stone foundations, field stone, stacked stone, and it's that's even some with mortar, some without mortar. It's just loosely stacked. And the wood, for some reason, that is in contact with that stone foundation, even after 200 years, and I did some exploration of some of these buildings, there's no rot on the foundation. So there may be some improvements in that area. I don't know of anyone who's kind of pursuing this. Like there's people who are pursuing cob construction and rammed earth and straw bale and various things. I'm not aware of anyone who's pursuing alternative improvements in foundation work. But I have observed that. I've noticed that, and I don't exactly know why. I do know that concrete tends to hold moisture and wick moisture. The moisture, it fills the cavities and it will travel up, and so that may be part of it. But yeah, the foundations, as far as I understand, as they are, concrete foundations, poured concrete, are very, very effective, very good. Yeah, they work really well.
Maybe one other parameter can be of interest here, and maybe Christoph can say something about it. Here in Portugal, we can build on lands that have no allowance for building a residence, but only if you do not pour concrete. So if you are not pouring concrete, and if it's a theoretically removable structure, you can build on agricultural land and you can live in the house. But otherwise, it's very costly. It's time intensive to get to change to a residential building. And if you just compress, like you just work with what is it, like pebbles, and you compress them, then it's possible to build on that.
Yeah, it was interesting when we were there. That's something that we ran into, was if it's not a masonry structure, stone, like granite blocks or concrete, they didn't consider it a permanent building. So they didn't really, you build what you like. We don't really care.
Very interesting.
And then speaking about roofing materials, so you'll see the most common roofing materials you'll see is shingles, asphalt shingles. They're called architectural shingles, and it's a fiber, like a fiberglass material mixed with asphalt, and then there's an aggregate that's glued on top, and that's the most common roofing material you'll see in the US. And that's the standard, shingled roofs that you see.
Let's take up roof next week. It's a whole topic. But let's take up roofing for the week after, because it's a whole topic by itself, and it's like informative.
Sure. We can do that.
Trying to figure out the walls, and this is very good what you are speaking about. So we have gone through log homes last week, and this week we are going through all the like earth and rammed earth and compressed earth and Earthbag. Then we haven't really spoken about deeply about the concrete blocks and also the stone. In India, many places they just build. Or brick walls also, like fired brick walls.
So there's an interesting thing. I don't remember if this came up when we were traveling together about bricks, but or if I learned this somewhere else. It may have been when we were traveling together. But in India, you'll see two different kinds of bricks. You'll see the British bricks and you'll see the Indian bricks.
Mhm.
The British bricks are the large ones that we're familiar with. These are standard, we consider them like a standard size brick. And they require a certain amount of wood or heat to fire them. And it requires more fuel. And the Indian bricks, you will see them in old pre-British buildings. So in Vrindavan, you'll see some. You may not see them anymore, but I remember when I was there in 2007,
I've
2008.
seen oven old small bricks.
Very thin. The bricks are very thin. They're like a third of the thickness, or half or third of the thickness of a standard brick. And the reason they did that is because this was before the British came, so they already had this.
Fired bricks. Yeah.
They used more sticks and smaller material to fire the bricks, and so the thin bricks allowed them to be fired at a lower temperature and still be fired properly.
I see.
And these bricks lasted for a ridiculous amount of time. It's amazing how long these bricks lasted.
In that one, we have seen like 400-year-old bricks. They are just lying there.
Yeah. And they're still there. They're not breaking down. And then you see right next to them the bricks that were built that were fired and put into the buildings during the shortly after the British had come, and they don't last as long because the temperatures are not able to be as well reached. And so the newer bricks, they deteriorate faster than the older bricks because of the necessity for the British established this system of, we do bricks this way, this is the sizes you need, and like that. But it was not really conducive to what fuel was available for making the brick. And so the quality was just not as good. So it's an interesting thing. Like I was saying before, I'm avoiding the concrete block and brick construction just because those are very expensive construction methods. The concrete block, not as much, but brick is very expensive in this country. It requires it's very labor intensive, and it requires skilled labor, expensive labor. And the materials are also costly. Brick is a very costly material. And so I think that kind of eliminates it from our ideas. I think there are much more cost effective and other ideas that would.
Such an exact science you have to be, because
it is very much an exact science. Like, people have to spend years and years training to become a good mason. Yeah, it's well, yeah.
How much difficult it is to build with this. So
That's
now
part of the reason you don't see as many brick structures.
in the US, there is practically, I've never seen a brick structure.
You will see them in old government buildings. That's typically where you'll see the brick structures, these old government buildings.
Or for ornamental beautification purposes in some walls.
Yeah.
But not.
And then stone becomes very complicated and very, very costly. The stone is a costly resource, and the skill to build with it is also not. It's expensive. So,
why is it so expensive to build with stone in the US?
mainly because the cost of the stone is very high.
Why?
It's it is not just kind of the infrastructure and the resources to bring it, to transport it, to build with it. It requires heavy machinery to move it. transport it. So
Well, I mean,
you'll find,
when gravel comes, that's also very hard, right? So the
yeah,
truck comes the gravel. These are smaller stones. And what's the problem if the bigger stones are brought and dumped, and then somebody can use it to build homes like this?
you can move the equipment to move gravel is simpler than to move larger stones. It's just it depends on how big they are. I mean, you can see, Bharat, we might have some input on the granite structures that you've seen in Portugal. I mean, it's incredible. They have the skilled labor and the knowledge on how to build with this. But my parents lived in a stone cottage, and it was made out of stone blocks, granite blocks, and most of the blocks were about as big as me. And the structure is probably over 1,000 years old. Oh, I think it was 600 years old is what they figured, is that it was a 600-year-old structure. And so it lasts a ridiculously long time. It's older than this country. But the skill required to work with these blocks is very specific, and I don't think it really is so available in this country. I don't know, but I don't imagine it. And so stone, even to work with smaller stones, you're working with an uneven surface. And so the time involved in constructing the walls and the structure is not it's much longer with uneven cut stones. And if you have to cut them, then the cost is higher. So yeah, it's
the R value is also very less. My God, 0.08 per inch.
yeah, it's very low, but the thermal mass is extremely high. So in the northern climates, I wanted to say something about the thermal mass. In the northern climates, a building with low R value but high thermal mass, this can be very useful. There's ways that you can do this. And typically what I have seen is that you put a reflective insulation. So it doesn't have a very high, it's not like a lofty insulation, like a large fluffy surface. It's a thin styrofoam or foam board insulation with a reflective surface on it. And the idea is it's like a radiant barrier. And you put that on the outside of the house with the thermal mass on the inside, or they can do either side. It depends on the approach. And the idea is that you are heating up the thermal mass of your walls by your heating inside the house. You're heating the whatever heating method you have. And the radiant barrier traps that heat so that it doesn't radiate out into the environment as much, and it radiates mostly into your living space. So once you get your house to the correct temperature, and the walls have adjusted as well, they've matched the temperature, then you find that, okay, now your cost to maintain that temperature is very low, because all you have to do is add a little bit of heat to the system to keep the thermal, keep the temperature. So that works very well for northern climates, but it's a question of kind of bringing the heat up to that temperature in the first place. So
it's tough in the winter and everything.
It can be, yeah. But with the radiant insulation, it works well. They do this in like Sweden and Norway and stuff.
Really?
But they do a lot of wood. Most of the wood construction comes from there. All of the wood construction that we see in this country, it was brought over to this country from Northern Europe. They have so many huge forests there, but buildings in log construction and the timber construction, those construction methods we learned from the Northern Europeans, from Sweden and Denmark and Norway, like that. So. No. Anyway, for Bruce? Anybody have any other questions? That's kind of the extent of my experience with this and my knowledge. Happy to have had this opportunity to I've shared what I know.
So we haven't talked about concrete blocks.
Yeah, the concrete blocks is very similar to brick. It's a little less particular in the construction because they're larger blocks you're working with. But again, you're working with masonry. It's very similar problems, very similar skill is required to construct with them.
Mhm. So I don't know what else to do other than concrete blocks in Florida because of the hurricane stress. Earthbag is the only other option, right? Other than that,
The compressed earth block will not tolerate the hurricane stress.
I don't know. We have to see. But other
I
than
believe that it is.
yeah,
I believe that it is comparable to cinder block construction, cement block construction.
it needs some steel reinforcement by law.
Yes, yes, and that's not in the blocks. That is, when you are building the wall, the block would be constructed with a hole in the center of it, and that would allow for you to put the steel reinforcement.
So it's saying hurricane extremely strong earth bags, especially
Yes.
are often described as near invincible, withstanding high winds and flying debris. The problem is some are on, let's say on this island, a flood can come. So they want us to build 6 to 8 feet above the ground level.
Wow.
We can't
Okay.
put these earth bags, huh? Or we
So here's
can.
what I would do. This is what we had to face, what the builders had to face in Mayapur. So what you would do is you're going to build a foundation. You're going to build like an arched foundation, and you're going to build up off the ground. So you're going to build these arches, and in Mayapur they use bricks. So you can build brick archways or concrete block archways. And then after you have that structure, that foundation, then you can build with your earth bags above that.
Oh, okay.
Because if you do any kind of timber legs like that, where you're lifting, the weight of the building is too much. You have to go with a masonry foundation, masonry legs. And now I found that as a very interesting construction. Now, in the Mayapur, in the Grihast area where I lived, it's a small village, there's must have been 20 buildings, I think, 20 or 30 buildings in a neighborhood design. And you have all these areas underneath the buildings, all these arched, areas underneath. And I thought, well, these would be great for storehouses or storefronts or workshops. And unfortunately, they were all being just left vacant. They were not designed to be used. They were just designed as structures. And so they can be, they're designed as supports, not as to be, kind of used for anything. So I was thinking that this would be really beneficial to make use of this space. So you build them 8 foot, and then you establish them as not living spaces. This is more like, oh, this is your doctor's office below your house. And if a flood comes, you design it in a way that, okay, if you move any equipment or things out of there before the flood, and it's all earthen and the concrete or whatever, and the flood leaves, and okay, you can move back in. It's not damaged by the water.
I see.
And so
it's
I
interesting.
want to chime in on that because that's where my house is. Hare Krishna, everyone. I've
Hare
been
Krishna.
listening in, and I just want to say that those raised buildings, those under the building areas are really great for animals, and because no animals were living there, actually often the street dogs would make their little homes under there. But mainly what lives under there is mosquitoes. So if you don't have anything living there, the mosquitoes will move in. We have a horrible mosquito problem there in Mayapur.
Oh my God, there
So I think it would be nice for cows and sheep and farm animals.
there's so many mosquitoes in Florida.
Yeah, so if you have those raised buildings where water can collect very easily underneath, then your mosquito population will thrive.
See.
But I imagine that perhaps if there's a certain type of like domestic animal, not domestic, but like farm animal living quarters, then it wouldn't have so much standing water because that's really how they breed and multiply.
Interesting. Here on the island, people use that as garages generally,
That makes sense.
because they have to park somewhere. And Mayapur may not be a problem. Everyone may not have cars. So here they always use cars they put under it, or they will use it as storage.
Yeah, some places in Mayapur they use it for their motorcycles and bicycles, but there's not such a need.
Yeah.
Like cars are so much bigger.
One could also use that as like shops, right? If whatever one is selling, one can put it downstairs. Right?
Yeah, that's what I was thinking. It would be very nice to do. It was unfortunate to see the structures not being used in Mayapur, and I thought, oh, this would be very useful. I mean, part of the reason it came up is we were growing grain and we had nowhere to store the grain. We stored it in our apartment. We had 2,000 pounds of rice in our apartment, and we thought, oh, it'd be nice if we could store this, had proper storage underneath the house. But yeah, so they could be very usable spaces. They would not be living spaces, but I think you could get them made acceptable as a a storefront or a doctor's office or something like that.
Interesting. So you build like an arch, concrete arch, and through the foundation, and then use that below space for whatever different purposes, multi-use. And on top you put earth bags, and those have earth mass. It was what I was looking at is the earth bags have thermal mass.
Yes.
Concrete don't. So it's so hot in the summertime. Like
Yeah.
summer here starts on March. So March to November, October, it's unbelievably hot and humid and mosquito. So you can't
So
really open up everything and just think everything will be fine because mosquitoes are there. So you need really insulated walls when you are inside. Otherwise, the energy costs are so high.
yeah.
People come to Florida to live in the winter, but I see everyone is inside in AC.
Yep.
We came here, we thought, oh, open the window, this thing, that thing was nice air. Mosquitoes started coming in. So we had to close everything, and we just sitting inside like in a AC thing. You can't do anything. So I don't know what to do. But big wall like these Earthbag walls could be good because they could provide the insulation necessary.
I was also looking at this compressed earth block. So essentially the engineering that would be needed, the way they do this, they would run rebar or steel bar through the walls. So you would have the blocks would be designed with holes in them. And the rebar can be run. So the rebar is embedded in the foundation. And then the blocks are stacked on top of this rebar. And at the top of the wall, then you have a top plate, a wooden plate that goes across the top, and the plate is bolted, so it essentially clamps down on the wall, and that ties your roof to your foundation. And so engineering it in that way, then now your compressed earth blocks become a monolithic structure where They're not the wind concerns of a hurricane. This is not so much of a concern anymore. So it can be done. It can be done very nicely also. So it is still an option.
Mhm.
But also I like the Earthbag is, is also very nice. So you have several options depending on the type of structure.
Mhm. Earthbag, concrete, what else? I don't.
Compressed earth block.
Compressed earth block. It's just the with the heavy rains. I don't know how long it is going to last. Or
You stabilize with lime with the blocks, and then they're fine. They will be stable in the wet. The unique thing about lime is that lime is essentially calcium carbonate, I believe.
Mhm.
And so what ends up happening is that it has been cooked and reduced back to its basic structure. So when it is mixed with water and it is formed into a block, or it is done as a plaster like we did on our walls in the cabin, it draws in carbon dioxide from the air and slowly turns back into limestone, that's what originally where it was constructed from. Sorry, the kids are being crazy here. So yeah, so it slowly becomes stronger and stronger. Just over time, that lime increases in strength. So it's advantageous to use that.
I wanted to chime in that lime might be very cheap and accessible in Florida because Florida is basically made of lime.
yeah, you're correct. All over we have crushed corn shells, roads here. Farm roads are all crushed corn shells, which is basically lime,
Yeah.
calcium. So before we finish, any questions anyone has? Any points?
Hare Krishna, Prabhu. Dandat Pranam, Prabhu. Pradyumni.
Hare Krishna.
Papa, I just heard that mosquito. So I was there in HKV, what we are doing that all we cannot avoid, there can be. So we used to burn that cow dung cakes when we are out for the aarti, and when we come back, then after that, like that can also be used because mosquitoes will be farm community means these things will be small insects and these things will be there.
I see. Interesting. Mhm. Okay, Prabhu. Hare
All
Krishna.
Prabhus.
Thank
Hare
you.
Krishna.
It was very, very useful, Prabhu. Thank you for spending your life in trying to figure out a good construction method. So you're able to, I mean, we can now with AI, everything, we can read everything, but we can see how personal interaction is so important to understand, because I had all these things, but I couldn't figure out what all, which will be good, not good. By personal interaction and experience, it becomes so much clearer. So this is very good to know. So the foundation and the walls we are trying to figure out. I'm so confident now of the strict frame and with straw bale in the northeast.
I think for your New York place, it is really ideal.
Even if we were discussing last week about putting log and straw bale, that will
Yeah.
make it, because we don't have a space problem.
Right.
So we
Right.
can make it strong and really durable, and have thermal mass too, and then the insulation R value too, and all these things are possible to do. So we can, but this is good. And so next week, shall we take up the roof part?
Sure. Yeah, we can discuss the roofs. What is the options there?
Great. Let's do that next week. Let's discuss the roof. And
Very good. Hare Krishna.
Krishna. Tanvat Pranam, everyone.
Hare Krishna.